All throughout our internet browsing lives, we have come across many of these. These are called completely automated public Turing tests to tell computers and humans apart, or in short, Captchas. In this video, we are going to create Captchas just like these, using images and Python. At the start, you'll need to import some of the required libraries, which are OpenCV for image manipulation, NumPy, and OS module. Captchas have been around since 1997, when they were first developed by surprisingly two parallel groups. This, however, was just not the beginning. In the early days of the internet, there were people who posted opinions on sensitive topics on internet, but fearing censorship as the keywords could be filtered, they came up with a new idea. The idea was to change English characters with similar looking numbers and special symbols. For example, speak became 5p34k. They still look like speak. This came to be known as leet speak, and it is often used even today, mostly in the community. Speaking of today, the captchas have really evolved, and now we use images, audio, and text captchas, all of them. As we know that there are no rules as to what should be the length of the captcha, we have basically left it to the computer to decide using NumPy's choice function. Well, there might be many different ways by which we can get our data related to the alphabets, basically the images of the alphabets. But I got my data from a public website whose link I'll share in the description. So I load the data and select randomly the n number of characters indices. Character indices means 0 corresponds to A and 1 corresponds to B and so on in the alphabetic order. Define some variables and now we are ready to go. Open a loop and iterate over every selected character index and choose the directory and then append the character to the real variable, as you can see here. So what is the real variable here? The real variable is just the captcha text that we will be using to verify the user input. Now from the directory, pick a random image, as all the images belong to the single alphabet. Then some basic thresholding of the image so the character appears in white pixels and the background in black pixels. And now the fun part begins. According to Wikipedia, captchas in general should have three distinct qualities. Number one is invariant recognition. That is, even when there is a large variation in alphabets, such as being converted to this, a human should be able to decide. The second is segmentation. It is the ability to separate one letter from the other. And so, even if these two alphabets seem to merge, a human can understand that these two are different alphabets. And the last one is context. It is when a character is understood only when it belongs to a particular word. The last one honestly does not make sense to me so much, as captchas in general do not come from a word. They are just random characters and alphabets stuck together. Okay, so in order to satisfy these properties, obviously except the last one, we are going to use some transformations, or basically three. The first one of them is shearing. So this is shearing. Shearing is just pushing a vector only in one direction. So you can see here that a vector is moved only in the x direction. So this is a small shear and this is a large shear. So in our case, we'll take a small random value for shear between 0 and 1. We also need to specify the direction of shear, as this is a x direction shear and this is shearing in the y direction. Now remember this if you don't already know, that most transformations, if not all, is done using matrices. And matrix for shearing in the x direction is this one, and for y direction this one. Then to actually apply the shearing transform, we need to use cv2.warpPerspective function. So this was the shearing function. And now let's see the rotation function. So rotation is actually simple. We first assume an angle in degrees and convert it to radians and apply the sine and cos function, which you will see in a second. So rotation of an alphabet will look something like this or this. Simple, right? So after having defined the rotation function, we'll assume a random angle using the np.radians function. Then for the rotation transformation, we'll be using this matrix and again use the cv2.warpPerspective function. Lastly, we will add our transformed alphabet image to the image list and run the loop as many times as the number of characters we chose earlier. So we have come out of the loop and now we need to stack all the individual alphabet images in the image list and get the final image. So if you look at the output, it's still okay, but a lot more can be done. So first we'll fix the background. For the background, we'll first select the background pixel location, which are black, and convert these to value 1, and then rest everything will turn to 0. We then take an image from some place and then find the dominant color, or to be precise, the pixel value that is most common in R, G and B component of the image. So for the Lena image, it will be red, or to some extent pink. Different images will have different dominant colors. So we will now define the expected value function and then split the image into blue, green and red channels. It appears that OpenCV follows the VGR order and not the general RGB order. I won't explain this part of the code as you need to understand some amount of statistics and understand what expected values are. So we will let that be. For now, just know that it gives us the dominant color. Then we will multiply the color vector, which is this that we got from the expected values function, and multiply it with the EM matrix. The EM matrix, as you remember, is one at positions that correspond to the background pixels in the image. The output is the mask, and we will add this mask to the captcha image and get the new captcha image. Last, we'll add a line using the lines function. For lines, we would want our line to span the entire image. And so, we would want our start coordinates to be somewhere on this line and ending on this line, so that we could join both the points and make a line like this. Lastly, we'll use the cv2.line function to draw a line. And finally, we get our results. So as you can see, this is the captcha. So there are many unique captchas that we can make. So finally, thank you very much. Please subscribe to my channel and the code is available on GitHub. Thank you.